Okay, a proton has an uncertainty in its velocity of 5.20 times 10 to the 6th meters per second. That's the total range. Okay, what is the minimum uncertainty of its position? All right, are we ready for this? Okay. Let's see. I think let's figure out, yeah, I got it. I'm on top of this. So the uncertainty of our momentum is mass to uncertainty of velocity. So that's 1.673 times 10 to the minus 27. So look that up. Look it up in your data packet, right? That would be the mass in kilograms is what we want, right? Okay, and then our uncertainty of velocity, this says the total range, right? So 5.2 times 10 to the 6th. Let's figure this out. The total uncertainty of my momentum, 1.673 e minus 27 times 5.2 e6 is, it's a small number. Is 8.6996 times 10 to the minus 21 kilogram meters per second. All right, so now we're going to plug that in for this guy and then solve for the x, right? So uncertainty in position, okay, is equal to, so that times 8.6996 times 10 to the minus 21 kilogram meters per second equals Planck's constant over 4 pi. All right, here we go. I can do this. 6.626 e minus 34 divided by 4 divided by pi. Where is it? There it is. Divided by the answer I just got is 6.06 times 10 to the minus 15th. Roughly the size of a nucleus, right? Minus 15th, a big one. Meters. Now you'd have to say this is the total range of where it could be, right? You'd have to say that its position has an uncertainty of 3.03 times 10 to the minus 15th, right? That would be, up that much, down that much. This is the total range, right? Yeah.